Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let's solve question number 14 of JEE Advanced 2014 Physics Paper 1. Let us solve question number 14. Students, let us solve question number 14. The question says two parallel wires in the plane of the paper. In the plane of, this is the plane of the paper. So in this plane we'll consider two parallel wires. Suppose these are the two parallel wires are distance x0 apart. So the distance between the two wires is x0. Okay, distance between the two wires is x0. A point charge is moving with speed u between the two wires. So between the two wires there is a point charge which is moving in the same plane. So it is moving like this or this in the same plane at a distance x1 from one of the wires. Suppose that this is the charge q which is at a distance of x1 from one of the wires. Suppose from this wire, this is our wire number 1, wire number 2. When the wires carry current of magnitude I in the same direction, so current in these two wires are in the same direction and both these currents are I. The radius of curvature of the path of the point charge is r1. Now, as this is moving with the velocity u, this particle is moving with the velocity u. If it moves like that, in what direction it is moving not given. Suppose I suppose it's moving in this direction, then the magnetic field due to this wire will, one wire is like that and the current is in this direction, so magnetic field will be out from this side into this side. So the magnetic field due to the first wire will be into the phase. It is due to the first wire, and if I consider second wire is here, then for this wire, this point, the magnetic field will be like that. So for this point, the charge will experience magnetic field in the upward direction. So the charge q experiences two magnetic fields. This q will experience into and a dot, both cross due to B1 and dot due to B2. Dot means is coming out, cross means going into, and they're opposite in direction, so we will take the net difference of the two. So if this x1 is greater, or depending on whether this x1 is greater or smaller, if this because the magnetic field due to a straight wire, there is straight wire current carrying current I at a distance x, the magnetic field is given by mu naught upon 4 pi 2I divided by x. So if x is more, b will be less. So depending on because this distance is x0, whether this distance x1 is more than the remaining distance. So we have to see that. But whatever, if it is more, then the curvature, the net magnetic field, suppose is into V1 is greater, this is into, and then the charge is moving in this direction. We'll apply QV cross B. QV is in this direction. Q is a charge, positive charge. Velocity is in this direction. So B, suppose is downward, net force, net B is downward, then the force will be towards left. So the charge will move towards the first wire. If magnitude of B2 is greater, then this will be upward, and QV is like that, QVB cross product, then the charge will move towards B1. If magnitude of first wire is greater, this charge will move towards first one. If magnitude of magnetic field is greater for this wire, the charge will move towards this side. So because both are present, and if this is more than that, B1 is greater than B2, then this will be moving towards this side. Suppose that I assume that it may be different, but that has nothing to do with our answer. We'll see. If in contrast, so radius of curvature is R1. In contrast, if the currents in the two wires have directions opposite to each other. Now in the second case, he reverses the direction. In this wire, upward direction. In this wire, he takes downward direction. In contrast, if the currents I in two wires have directions opposite to each other, the radius of curvature of the radius of curvature of the path is R2. If x0 by x1 is 3, and find the value of R1 by R2. Students, so this information is given, x0 by x1 is 3. So x1 is x0 by 3. So therefore, if this is suppose x2, suppose that this is x2, then that x2 will be x0 minus x1, that is x0 minus x0 by 3, that is 2x0 by 3. So if this is 1/3, then this is 2/3 of the total distance. That means this distance is 1/3. So this distance is less. So if this distance is less, then B will be more. So for this case, the magnetic field due to this will be more. So the charge will move towards the first conductor, something like that. It will move like this path. It will move like that. If it moves like that, it will have a radius of curvature. Suppose that is R1. That is given R1. If I reverse the direction, the radius of curvature will be R2. It says R2. Then what is the relation between this R1 and R2? If this is the center and radius of curvature of this path, this is the trajectory of the projectile, the charged particle, this is suppose the radius formula, and that suppose at any instant the velocity is u, and obviously it will change, but at any instant the velocity is u, and to move in a curve it requires a circular path, because the magnetic field will move the charged particle in a circular path. For a circular path, there must be a centripetal force. So this centripetal force must act towards the center, which is given by mv square, that is u square by r1 here, and that is provided by the magnetic force. The magnetic force is q u b sine of theta, where theta is the angle between the u vector and b vector. U vector is this and b vector is into, so the angle is this is the b vector, that is b1 minus b2 in fact, which is downward, and therefore this is the net b net which is present there. This is the b net because it is under the influence of both magnetic fields due to the first and second wire. One is down and other is up. The net is down. QUB net sine theta, and theta is always 90 because the charge is moving in this plane of the paper and the B is perpendicular to this. So theta between this U and B is 90. So if I put this, then this is that U1 U will cancel out, and R1 comes out to be mu upon QB. This is the formula we are getting. R1 is mu by QB in both the case when there is another situation when the current is posed up this side and down this side, and the charged particle is moving. The charged particle is moving. This magnetic field will be down, and due to this the magnetic field also will be down. So magnetic field of both will add up, and this B1 plus B2 will be the net magnetic field. So if it is into both the case, then it will move toward the first wire depending on which side I have changed the direction. If I change the direction of this one, this is down, suppose this is up, then it will be up. If it's up, then this will move towards this side. Okay, so this will move toward this side or that side. So this will move toward this side or that side depending on which side of the conductor you are changing the direction. So because that has nothing to do with the result, so supposing that I have taken this side down, so here the particle will move again in this side. Here B is more, and as you can see that if B is more, then R will be smaller, so it will sharply bend, and something like that, this type of curve will get instead of a flat curve. But in this case, whatever is that is radius is R2 in this case, and R depends on only on B because mu and Q are same in both the cases. So in this situation, the radius is R2, which is mu upon Q B net. Here is B net, here also B net. That means R is inversely proportional to B. If I divide that R1, because we are concerned with R1 upon R2, I will find that this R1 upon R2, from that expression I will get mu upon QB net. First case, divide by mu upon QB net in the second case. This is case 1, this is case 2, so I write prime. So this mu and QQ will cancel out. R1 upon R2 is B net in the second case divided by B net in the first case. This is not square, it is the second case. So first case to second case we have to find and put this in this expression to get the answer. Now how to find that? So if I go back to the expression, because I know that two conductors are here and here, the magnetic field at a distance of x naught by 3, and this distance is 2x naught by 3. This total distance is x naught. Field due to this one is down. that is B1 is down and B2 is up. So when the current is I, and then B net in the first case is B1 minus B2. B1 minus B2 because B1 is smaller, so that will be greater, B will be greater. So then we know that at a distance the formula is mu naught upon 4 pi, 2 times the current that is present by x. X is for this case it is x naught by 3, sorry, is x naught divided by 3 minus 1 by that 2x naught by 3. So if I solve that, I'll get B net in the first case is equals to, that is mu naught upon 2 pi I divided by x naught, because I'm writing from here this one, 2 will cancel out, mu naught I upon 2 pi and x naught goes out, so it is 3 minus 3 by 2. This comes out to be 3 by 2. 6 minus 3, that is 3 by 2, 1.5, 3 by 2. So it is mu naught upon 2 pi I by x naught and 3 by 2. If I see the same thing for second case when the current is reversed, then B net I will find in 2. In that case the B will get added up, and in that case this will be mu naught upon 4 pi 2I by x. First the x is x naught by 3 minus here plus 2x naught by 3. So x naught goes out, here it is mu naught I upon 2 pi x naught, and this is 3 plus 3 by 2. So that is only a change in the sign of this, only that is change in the sign. So now if I put this plus here, then this is 9 by 2. So mu naught upon 2 pi I upon x naught, and this is 9 upon 2. If I use the form, put these values over here in this expression, what I will get? Now I have to put this value because these two are same and will cancel out, and we will get R1 upon R2 is B net second case divided by B net first case. This is B net in the second case is mu naught upon 2 pi I upon x naught 9 by 2, that we already got, divided by the first case it was mu naught upon 2 pi I divided by x naught, and this is 3 by 2. So if I solve this, then this will cancel out, this whole thing will cancel out, and this 2 will also cancel out, and this is 9 by 3, it becomes 3. So in terms of the digit, the answer is 3. So if this is the question which is asked to find what is the ratio R1 by R2, then is what is the question? The answer is 3. This is the answer. Okay, thank you.